high. So this is the algorithm. First we will call this algorithm. This algorithm return the pivot element index. So based on the pivot element we will do the partitioning. So first for the left part, QuickSort of array low comma j minus 1. So this one is the left sublist. Again we will apply the QuickSort for the left sublist. So for example, pivot element index is j. Before the pivot element, list of elements are left sublist elements. After the pivot element, elements are right sublist elements. So from 0 to j minus 1. So these are left sublist elements. From j plus 1 to high, right sublist elements. So again we will apply for the QuickSort for the left sublist, and again apply the QuickSort for the right sublist as well. Array from j plus 1 to high. So these two algorithms are recursive algorithms. These two algorithms are called recursively until the list of elements consists of only one element. It will be called repeatedly. So these are the recursive algorithms. So these are the algorithms for the QuickSort. Two algorithms. First one is partition algorithm and second one is QuickSort algorithm. And next one, analysis of QuickSort. So analysis of QuickSort. So what is the analysis of QuickSort? What is the analysis? Analysis means we have to compute the time complexity is called analysis. So analysis means we will compute the time complexity for the best case, average case, worst case. So for these cases we have to compute the time complexity, that is called analysis of QuickSort. So for the best case, average case, what is the time complexity of QuickSort? So when will be the best case and average case will be occur? If the pivot element would be in the middle position, and form the two sublist, left sublist, right sublist, and form the two sublist, left sublist, right sublist. So for these type of elements, the best case and average case time complexity will be occur. So if the pivot element would be in the middle position and form the two sublist, left sublist, right sublist, for these type of elements, the best case and average case time complexity will be occur. So the total time complexity of n elements equal to, for the left sublist, to find out the time complexity for the left sublist, T of n by 2, for the right sublist, T of n by 2, for the partitioning n. So this is the recurrence relation for the best case and average case time complexity of QuickSort. So to sort the left sublist elements, the time complexity required is T of n by 2. To sort the right side sublist elements, the time complexity required is T of n by 2. For partitioning of n elements is n. So the recursive relation for the total time complexity of n elements is T of n by 2 plus T of n by 2 equal to 2 into T of n by 2. 2 into T of n by 2 plus n. So this is the recurrence relation. We can solve the recurrence relation using, there are two methods are there, substitution method and second one is master's method. Substitution methods are two methods, backward substitution, forward substitution. So we can solve this recurrence relation using substitution method or master's theorem. We can use any of these two methods, any of one method we can solve this recurrence relation. So the recurrence relation is T of n equal to 2 into T of n by 2 plus n. So by solving this recurrence relation, the time complexity we will get is order of n log n. Order of n log n. Next one, worst case. Worst case time complexity. So when will be the worst case time complexity occur? If the, for example, the elements will be like this 1, 2, 3, 4, 5, 6, 7. The elements will be like this. By observing these elements, the elements are already sorted order. I am taking first element as pivot element. So after partition done, what will happen? So 1 is the pivot element and form the right sublist only. There is no left sublist. So if the pivot total elements are n elements, 1 is the pivot element and remaining n minus 1 elements at the right side only. Again for the n minus 1 elements, again apply the QuickSort. So 1 is the pivot element and remaining n minus 2 elements at the right side. And again apply the QuickSort. 1 element is the pivot element and remaining n minus 3 elements are at the right side only. So and so on, doing this process, n minus 1, n minus 2, n minus 3, n minus 4 and so on, n. So this is the formula for sum of natural numbers 1 plus 2 plus 3 plus and so on plus n. The formula is n into n plus 1 by 2, that is order of n square. The time complexity is order of n square. So when will be the worst case occur? If the elements are already sorted order. If the elements are already sorted order, then only the worst case will be occur. But based on the pivot element, the time complexity will be varying. I am taking first element as the pivot element. Now I am getting time complexity is order of n square. For these list of elements, I am taking 4 as the pivot element. Then it forms the 2 sublist again. Left sublist consists of 1, 2, 3 elements. Right sublist consists of 5, 6 elements. So this is the we can calculate the time complexity. Then we will get the time complexity is order of n log n. So what I am trying to say is the time complexity is based on the choosing of the pivot element. If the based on the pivot element, the time complexity will be varying. For the same example, we will get the time complexity order of n square if the pivot element is the first element. For the same example, if the pivot element is middle element, the time complexity is order of n log n. So the time complexity is varying based on the pivot element. So this is the analysis of the QuickSort. Thank you.